How old is the Earth? Some will tell you it's a sprightly 6,000 years old, while scientists confidently state it's a staggering 4.5 billion years old. That's a huge difference. So who's right, and how can we possibly know the true age of our home planet? Let's dive in and solve this cosmic mystery. The 6,000-year figure often comes from religious texts, specifically by counting back the generations listed in the Bible. This method, popularized by Archbishop James Ussher in the 17th century, calculated a creation date of 4004 BC. For centuries, this was the widely accepted age in the Western world. It's a fascinating piece of history, but it relies on a very specific interpretation of ancient texts, not on physical evidence from the Earth itself. So where does the 4.5 billion year number come from? This isn't just a wild guess. It's the result of over a century of brilliant scientific detective work. The key is something called radiometric dating. Think of it like a natural clock built into the very atoms of rocks. Here's a simple way to understand it. Certain elements like uranium are unstable. Over incredibly long periods, they decay, transforming into other elements like lead. Scientists know the exact rate at which this decay happens. It's called a half-life. The half-life of uranium-238, for example, is about 4.5 billion years. This means that after 4.5 billion years, half of the uranium in a rock will have turned into lead. By measuring the ratio of the original element, the parent, to the decayed element, the daughter, in a rock sample, geologists can calculate how long that rock has been around. It's like finding a magical hourglass where you know exactly how fast the sand falls. By checking how much sand is at the bottom, you can tell how long ago it was flipped. But wait, you might ask, how do we find the oldest rocks on Earth? It's tricky because our planet is very geologically active. Plate tectonics constantly recycle the Earth's crust. Old rocks are melted down and reformed. The oldest rocks we found on Earth's surface are about 4 billion years old, located in places like Canada and Australia. This tells us the Earth must be at least that old, but it doesn't give us the full picture. To find a true birth date of our planet, we need to look for materials that formed at the same time as the Earth but haven't been recycled. Where can we find such pristine samples? The answer lies in space. Meteorites are fragments of asteroids that have crashed into Earth. These are essentially leftovers from the formation of our solar system. They've been floating in the cold, stable environment of space for billions of years, perfectly preserving their original composition. When scientists apply radiometric dating to these meteorites, they consistently get an age of around 4.54 billion years. And it's not just meteorites. Rock samples brought back from the moon by the Apollo astronauts also date to around this age. Since the entire solar system, the sun, the planets, the asteroids, all formed from the same giant cloud of gas and dust at roughly the same time. The age of these meteorites and moon rocks gives us a very reliable age for the Earth itself. So, when we put all the evidence together, the age of the oldest Earth rocks, the consistent dating of meteorites, and the samples from the moon, a clear picture emerges. The scientific consensus is strong. Our planet Earth is about 4.54 billion years old. It's a number so vast it's hard to truly wrap your head around. If you condensed Earth's entire history into a single year, the first complex life would appear in September. Dinosaurs would roam from mid-December until the 26th. And all of recorded human history? That would flash by in the last minute before midnight on New Year's Eve. Thinking about this immense timeline is not just a fun fact. It gives us a profound perspective on our place in the universe. It shows how long and complex the journey has been to create the world we live in today. From a swirling cloud of dust to a vibrant, living planet, the story of Earth is one of deep time, constant change, and incredible resilience. So, while the 6,000-year idea is an interesting part of human history and belief, the physical evidence written in the rocks and stars tells a much, much older story. And that story is still being written, with us playing a tiny but significant part in its latest chapter. Thanks for joining me on this journey through deep time. If you found this fascinating, hit that like button and subscribe for more cosmic explorations. See you next time.